Okay, we're going to look at implicit differentiation here. So the difference here is normally when we're deriving something, you have y is equal to a bunch of terms, and x is really the only term in it, right? And that's why you'll usually write it as f of x. In this case, we're unable to isolate for our y. Well, for whatever reason, this is the formula they've given us. So we need to derive a function when y is involved in it. So what we're going to do here is what's called implicit differentiation. I'm going to break these into terms. Okay, so this is term 1, term 2, term 3, and term 4. And really the difficult part of this is going to be term 2 will be the hardest part, term 3 the second hardest part, and 1 and 4 will be actually really simple for us. So I'm going to do them in kind of an odd order. I'm going to start with number 4. First I'll write out how this would kind of look. Normally what you'd write is d over dy, oh sorry, no, dx, sorry, derivative over dx, derivative of x squared, okay, plus we want to find the derivative d over dx of our second term, which is 3x squared y squared, plus we want to find the derivative of d over dx of 3y cubed, and again we want to find the derivative of dx of 451. So essentially what this is saying is just find the derivative of each of these separate terms in here, okay? 4 is really simple. Because it's a constant term, derivative of a constant is going to be 0, right? So that part can kind of just be simplified as the value of 0. So that's our term 4. Our term 1 is the same idea. This is a pretty straightforward derivative. This just becomes 2 over x. So we got, or sorry, 2x. Sorry. So that's part 1 and part 4. Very simply done. Like we said, 2 and 3 will be the hard part. So I'm going to break up. So our answer is kind of be in the middle of our page here. I'm going to jump down here for 3. For 3, what we're going to do is we're actually going to derive it, but because the y is still involved, we're going to kind of multiply it by our y. So the way we would write this term is we would now write it as dy over dx, and we're actually going to find the derivative of it. So dy dx is going to be multiplied by this derivative here. So derivative of that is technically 9y squared. So we're going to keep that multiplied. So this dy dx, almost think of it like a term we're multiplying by this now. It's still attached to it because we had to derive a value that had y in it. Okay, does that step okay? Okay. The hard step here is number 2. And I know I wrote 3 out here. We're going to actually do number 2 on the bottom. Number 2 is technically, because there's an x and a y involved, think of it like a product rule. Okay, so we're going to find the derivative d over dx of 3x squared, so that's one term, and y squared. So this is like a product rule. So if this is my h at x and this is my g at x, when we're doing product rules, we find h prime x first times g at x plus h at x times g prime x. Okay. Well, the derivative of an x value we can do. What's going to happen here is it's just going to be the value of 6x, okay, so we do the first part, times y squared. So that's our first step there. Our second part here we're going to find is our y value here. So this will stay the same, and we have 3x squared, but when we multiply it, it's going to be multiplied by 2y. So think of it like 2y. And we'll kind of have to simplify that. So this will be written as 6x times y squared plus, we can multiply the constants, or sorry, the coefficients, so that becomes a 6, and then x squared times y. So what's important here is, if you noticed above, when I was deriving just an x value, I dropped my d over dx, right? And when it was a constant, I dropped my d over dx. When I derived the y value, I kept it. So because of this product rule, in the first set, we derived the x, so we can drop the d dx, so it doesn't have to be put here. But in the second part here, because we derived the y, I actually have to still include, at the end of this, dy over dx. So anytime we derive the y value, we have to attach this to that value. like I said, we kept the dy over dx. So this whole part here is going to be put into our equation. This is the missing value. I'll just kind of highlight what's missing. This is what's going to go in there. So I'm going to rewrite everything a little, or just below it. Okay. So now term 1 became just 2x. Term 2 is what we just had written above here. Okay. So plus 6x times, so I'm just going to write 6xy squared. Okay, I don't have to include the dy over dx because I only derived the x value. In the second term of it though, I know this is all technically part 2 here, even though it looks like it's been split. This becomes 6x squared y, and then think of it like multiplied by dy over dx. Okay, that part has to be included there because we derived a y. Our third term, again, we derived a y. What do we get? 3y to the power of, should have been to the power of 2. I wrote that wrong. Does that make sense?
Yes.
Okay, good. So plus 3y to the power of 2 still has to be kind of like times dy over dx because we derived a y value. And then our constant was 0. That was our term 4. Okay, great. Do they want us to solve? They want to solve for a value here. So the whole goal here is to get dy dx by itself on its own side. So this is what we're going to do. I could write in a let statement, let dy over dx be equal to like z, and the whole idea is to isolate z. But hopefully you're okay with what I have written here. So this is the goal, isolate. I'm going to move these terms to the other side of the equation because there's no dy dx attached to them. So I'm going to bring them over. So when we do that, we'll get 6x squared y still times dy over dx, okay, plus 3y squared times dy over dx, okay, is equal to the 0 minus 2x, x becomes negative on the other side, minus 6xy squared, okay. So what we've now done is dy dx is by itself. And if you remember something called common factoring, I can common factor out dy over dx. So if I do that, it becomes dy over dx times whatever the other two values are. So the other value is 6x squared y plus 3y squared. Okay. So I've common factored that out. So now it's only one variable is equal to, the 0 kind of drops off, negative 2x minus 6x y squared. Okay. And to isolate, because this is technically multiplication, I need to bring this over. I need to bring this stuff over, and when I bring it over, I need to divide. So dy over dx is going to be equal to negative 2x minus 6xy squared over 6x squared y plus 3y squared. We've now derived the function. The function is derived, and this is our, it can probably be simplified with a bunch of other stuff, but this is our derivative of our function. So the idea of this change in y over change in x, it can be kind of written like this. There we go, change in y over change. This is known as the slope of an equation, okay? Or sometimes they write it as m, and when it's written as y equals mx plus b. So this is the slope, and dy over dx, that's the change. So they've told us at this point, they've given us a coordinate. What was the coordinate? 1 and...
Negative 1, 5.
So at negative 1 and 5, what is the slope? Well, this is the x value and this is the y value. So we're going to plug them into this to find out a value for slope. Okay? So we get negative 2. Our x value is negative 1. Right in blue. 1. Subtract 6 times negative 1. The y value is 5 squared divided by 6 times the x value is negative 1. That's going to be squared. The y value, so times 5 plus, it's a huge question, 3 and then 5 squared. Okay, let's see if I can do this as best as we can. Negative 2 times negative 1 is going to be 2. That's going to be 25 times negative 1 is negative 25 times 6 is positive 150, I think. If you have a calculator, just double check that.
What was it?
5 squared is 25 times negative 6 times negative 1.
Yeah.
Good. Okay. This is going to be 5 times 6. This is where I talked about that associative. Doesn't matter what order. 30. Negative 1 squared is positive 1, so that's just going to be 30. And this is going to be 25 times 3 is 75. So we're going to get 152 over 105, which I think... Okay, so I've made an error right at the beginning. Maybe you noticed. 3 times 3 is 9, not 3, so that should be the 2 there. So that's going to just change a small part, luckily. It's not a huge part of this. This should be 9y. So I'm going to quickly jump through. This should be 9, okay? Which means this should be 9, this should be 9, which means this should be 9. So it's just going to change our number on the bottom just a little. That should be 9. I'm glad at least we picked it up, kind of. So when we're adding everything together, oh, sorry, the 30 is right. It's the 75, that's a mistake. 30. This becomes 25 times 9. 225? No.
Yeah.
225. And 225 plus 230 is 255. Is that what they got? There you go. So that's the answer. I made a very small error at the beginning. But that's the part.